Hi, my math 40 plus students. So I wanted to start this first part of the recording a little bit early because I had recorded 5.6 or so, I thought, in the last meeting, but it didn't actually go through. So I did not record that part yet. So what I'm going to start with is a video about 5.6, just going over the formulas and the problems. I'm going to skip the derivation for now because we will have chapter 6 later today. Okay, so let me go ahead and draw in here. So this is section 5.6, half-angle identities. We're going to go over classroom example 1 and 2. And then just plug in the formulas here. So first and foremost, let's fill in this box. In the following identities, there's going to be a plus minus symbol. And you need that plus minus symbol, okay? It will indicate that the sign is chosen based on the function under considerations and the quadrant of a over 2, okay? So let's just write them out here so it's a little bigger. Cosine a over 2. That's going to be equal to plus minus a square root 1 plus cosine a divided by 2. Sine a over 2 is plus minus square root 1 minus cosine a over 2. And tangent a over 2 actually has 3 different formulas. One is plus minus square root 1 minus cosine a divided by 1 plus cosine a. It's also equal to plus minus sine a over 1 plus cosine a. And, oh, sorry, don't want to root on, hold on, let me explain that in a second. I'll wait on the explanation, hold on. Okay, and then the last formula, 1 minus cosine a over sine a. Okay, so just a quick explanation of that. You only want the plus minus signs when you have a square root next door. Okay, give you a little bit of insight. I would like to go over this maybe in a different video, but you can derive these with double angle formulas. Essentially, you can think of theta being equal to a over 2. And then 2 theta would be a. Let me save a picture of that. And then there's also one more formula for the tangent part that I always like to throw in. Remember, tangent a over 2, that's also just going to be sine a over 2 divided by cosine a over 2. Okay, let me go ahead and clear all this out. Classroom example 1, find the exact value of sine 22.5 degrees using the half angle identity for sine. So first thing we're going to do, we have sine of 22.5. Okay. And we want to know what it equals. Use your formula. So you have sine a over 2 is equal to plus minus square root 1 minus cosine a. Extend that square root over 2. All right. And then essentially from here, we're going to have sine 22.5 degrees on this side. Okay, so a few things when you pick your sign for sine. You're going to want to pick based on where this angle is. This is actually going to be a over 2, which is in Q1. So sine of a over 2 for this case is going to be positive. Okay. Now, kind of think if a over 2 is equal to 22.5 degrees, what would a be? We'll multiply 22.5 degrees by 2. You get 45 degrees. So we're going to have 1 minus cosine 45 degrees divided by 2. So then we just solve that out. 1 minus cosine 45 degrees is root 2 over 2. Then divide all that by 2 under the radical sign. You're going to want to get an LCD for this numerator here. LCD is going to be 2. So you have your square root. You have your 1 minus, change your 1 to 2 over 2, LCD 2. And then subtract your root 2 over 2. And then divide all that by 2. Gives you 2 minus root 2 divided by 4. So remember, you can combine these fractions first and then use an old school division inside the radical sign. So that comes out to, split your roots, square root 2 minus square root 2. Okay, this is a quantity underneath the radical sign. Divided by square root of 4 is 2. So oh, hold on 1 second. Oh yeah, okay, so just note I'm recording right now. Do you mind being recorded asking a question?
Oh yeah, I'm all good. I have a question. If I gotta go and do something, are you recording? You kind of just answered my question actually.
Okay, yeah, I am. Here, you want me to pause it?
Oh no, it's fine. Like I'm allowed to like come back and like watch this recording, right?
Oh, absolutely, yeah.
All right, cool. Cause I gotta go and do something. I just wanted to like make sure. All right.
Okay, yeah, that's cool. Yeah, so I'm actually gonna be recording and taking a few breaks, and then we'll actually be in this room until 3:30 today. So if you want to stop by anytime, you can. Okay?
All right, bet. Thank you.
All right, cool. Bye. All right, so wrapping this up, sine 22.5 degrees is equal to square root 2 minus root 2 divided by 2. Okay, we save that. If you need to take a picture, I'm going to clear that out, go over classroom example 2, and then I'm going to get into chapter 6. All right, let me clear this out. Okay, classroom example 2, find the exact value of tangent 75 degrees. Not the color I was looking for there. Okay, just doesn't say. Okay. And it actually gives you a particular identity to use here. So the identity that it gives you is this form. So that's tangent A over 2 equals sine A divided by 1 plus cosine A. Okay, so again, match form. Tangent 75 degrees. That means A over 2 is 75 degrees. So A is going to be twice 75, which is 150 degrees. So tangent 75 degrees is equal to sine of 150 degrees divided by 1 plus cosine 150 degrees. Okay. Note might help you to draw out here. 150 degrees is right around here. Reference angle 30 degrees. Okay, so sine of 150 degrees is going to be equal to 1/2. And cosine 150 degrees is equal to negative root 3 over 2. Sorry, that's pretty small. All right, so over here, tangent 75 degrees is equal to sine of 150 degrees is 1/2. And you're dividing that by 1 plus cosine 150 degrees is negative root 3 over 2. Okay, so let me save a picture of this. I'm going to clear the top portion out so I can move this up and work on it. Let me select this first. Okay. All right, so the algebraic part starts. Tangent 75 degrees is equal to, you have 1/2 divided by LCD on the bottom is 2. So 1 becomes 2 over 2. And you will now be subtracting root 3 over 2. That's equal to 1/2 divided by 2 minus root 3 divided by 2. Remember your denominator trick, or you can just write old school division now that you have a fraction divided by a fraction. 2's cancel. And you have 1 over 2 minus root 3. Okay, now if you get something like this though, you don't want to leave a root in the denominator. You might not remember this because it was algebra review from like our first week many months ago, but we're going to go over how to rationalize this next. Let me save a picture. Okay, let me clear this. Okay, this. All right, here we go. Jeez, here we go. Okay, to rationalize, you need to use the conjugate the denominator. Essentially, remember, if you have a plus b, the conjugate would be a minus b. So in this case, we have 2 minus square root 3. So the conjugate would be 2 plus square root 3. We're going to multiply the numerator and denominator by the conjugate. Okay. All right, save that. Sorry, I'm erasing quite a bit, but it's because I don't want to have to deal with flipping back and forth with the whiteboard right now. It has its own individual issues. Okay, so here we go. Multiply top bottom by the conjugate. Okay. On the top, we get 1 times 2 plus root 3, the quantity. So we just get 2 plus root 3. On the bottom, we have 2 minus root 3 times 2 plus root 3. Top stays the same. Bottom, FOIL it out. You get 4 plus 2 root 3 minus 2 root 3 minus 3, because root 3 times root 3 is 3. What happens here? You get rid of the radical terms. So you have 2 plus root 3 divided by 4 minus 3. 4 minus 3 is just 1. So tangent of 75 degrees is equal to 2 plus root 3. All right, so that covers 5.6. I'm going to get started with a different video for chapter 6.